Good afternoon, everyone, and welcome to WASA Distance Education. This is Foundations for College Mathematics and Grade 11 College Preparation, and my name is Marvin. Welcome to week 3 of 9 of this semester or this term. We are plowing our way through the first unit. It's taking a little longer because this is probably the most complicated unit of the four. So we're going to spend a little bit more time on this one, but we'll have plenty of time to complete the course on schedule. So we last week we looked at the different forms of a quadratic equation and what information we can get from each one and how it can be used to help us graph. So the last one we looked at was the factored form of an equation. We As we worked through the examples last week, we also use Desmos to plot the graphs just to verify that what we were getting as solutions mathematically were actually the solutions on the graph. So we could get, so for example, in the vertex form of the equation, we get the vertex, and if it's shifted right or left, up or down, if it's stretched or compressed. So we can get a lot of information from that form of the equation. When it's simply a trinomial like x squared plus 2x minus 24, that will only give us the y-intercept. And if we factor x plus 6 times x minus 4, that will give us the x-intercepts, which are sometimes called roots and sometimes called zeros. So it depends on the problem we're trying to solve, but most people refer to them as roots or zeros. And we refer to them as zeros because the y-coordinate of the x-intercepts will always be 0 because we don't want to go up or down anyway. In order to stay on the x-axis, then the y-coordinate has to be 0. Because if it was 1 or minus 1, you would be above or below the axis, and then it's not the intercept. So we looked at that last week, and we worked through some problems. And so today, uh, before we get started, I'll give you my contact information again. It's marvin.osment@nnecschools.org, or my cell phone number is 807-738-2031. If you are working on the course on your own and you have completed any of the lessons, even if it's just one lesson, then you should send it out to me so that I can mark it, send it back. That way, if you are making any mistakes, we can nip it in the bud early and hopefully take corrective action so you don't make those same mistakes moving forward. If you do 5 to 10 lessons, so half the course, and you make mistakes all the way through, then you're going to lose marks that maybe you wouldn't have lost if you had submitted each lesson individually. So early is better than later as well. So if you've completed some, please send it out. Typically, if you send it out, I try to mark it the same day and get it back to you the next day. So the most you'll have to wait is the following day. So keep that in mind. And again, it's better to catch problems early rather than later. And that will improve your mark as well. So we've been looking at the different forms of the equation, different information we get from the different forms of the equation, how that can be used to help us graph the parabola. And again, the parabola is what you get when you graph a quadratic equation. And a parabola is a U-shaped curve that opens up or down. And the very top, if it opens down, or the very bottom when it opens up, is called the vertex. And by definition, it's the point where the graph changes direction. So those are things that we've covered to date. So what we're going to look at now is how we can use quadratics to help us solve word problems. There is an example in the module, which I'm not going to go through with you, but I've added another one. So it's sample problem number 3.3. So let's work through this one together today. And then that will finish off the quadratics part of this lesson. And then we'll move on to something new. So a baseball is thrown upward from the top of a cliff. So you're standing on the edge of a cliff. You take the ball and you toss it into the air. It goes up. Now, of course, we have gravity on Earth. So what goes up must come down. So we throw it upward, it goes up, it reaches a maximum height, and then it falls down and it goes. So we're standing at the base of the cliff, and it's going to go over and it's going to go all the way down to the ground, which is far below the cliff. So that's the problem we're looking at. So the trajectory means the path that it's going to follow. So if you could, you can actually do this if you have a camera that takes photographs at I think it's called sports mode. So it goes click, 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 click. It takes a series of photographs. So if you were to set your camera up on a tripod and then have someone throw a ball into the air and watch it as it comes down to the ground, the path that the ball takes is actually a parabola. Will always be a parabola, can never be anything but a parabola. Okay, so an object that goes into the air, when a pitcher pitches a baseball, when a batter hits the ball and the ball flies to the outfield. Now, the parabola could look different. It could, if it's a line drive, it's going to be almost flat, but there will be a bit of a curve. If it was a high fly ball, it's going to go way in the air and it's going to come back down. So there's different shapes and different sizes of parabola, but they are all indeed parabola. Okay, so if it's a parabola, then we can create a quadratic equation to model the path that that ball takes. And again, if you took a camera, you took a photograph and we'll click, 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 and then you put all those photographs together and you look at the ball, you would actually see the shape of that parabola. Now, if when you think about when we throw a ball off the cliff, we're only worried about the part where we're standing and then where the ball goes into the air and goes back down to the ground. That's the only part of the graph that we're interested in. The graph will extend in both directions forever, but we're only interested in that one part of the graph. So in this particular case here, the trajectory can be modeled by the quadratic equation h equals minus 3t squared plus 6t plus 72, where h is the height of the ball above the ground in meters and t is time in seconds. So h and t, height, time. So that's why we use the variables h and t instead of, we could have used y equals a negative 3x squared plus 6x plus 72. The variable doesn't matter what the letter we use, but in case when we're doing word problems, we try to do it so that the letters kind of make sense. I begins with an H, T begins with a T, so we're going to use those as the variables in this particular case. So there we have the equation. So the first question says, what was the height of the cliff? So the cliff, if you were thinking about the graph, would be where we're standing at on the y-axis. Y-axis is the vertical axis. So where am I standing on that y-axis? And the hint is t is equal to 0. So when you work on a problem like this, the what I always do, and I always suggest, is the very first thing you need to do is to write the equation. So I'm going to make sure that I put the equation in there first. So that's how I start my solution. So what I will actually do, because this is a word problem, I'm actually going to write solution above there. Uh, you'll know it's a solution because I'm putting it in red, but if you were doing this, you might not do it in red. So the first thing we've done is we've entered the equation. Now the next thing we're going to do is we're going to do the substitutions. Not that we need to in this particular case, but we'll do it anyway. I just want to illustrate a point. So t in this case is 0. So if I replace t with 0 squared plus 6 times t is 0. Now, don't forget, when we have a number in a bracket and another number outside of the bracket, it means we are multiplying. Okay. So now we are we've got the substitution done. That's the first part. Substitute the value of 0 into the equation for t. Now we are going to simplify that. 0 squared is 0, and 0 times 0 is, of course, 0. Plus 6 times 0 is, obviously, again, anything times 0 is 0, plus 72, and then we are down to 0 plus 0 is 0, and 0 plus 72 is 72. So we know that the height of the cliff is 72. And in the last step is where I like to put in the units. So the units in this case is meters. So we are 72 meters above, that's the height of the cliff. Now, of course, in mathematics as well, whenever we solve a problem, I'm going to put this all down on the next page so everything stays together. Whenever we solve a word problem, we do the solution, and then we always have to put in a statement. And the statement will be, therefore, let's answer the question. Height of the cliff, height of the cliff is 72 meters. Okay, now, and again, as we mentioned earlier, this form of the equation here, this part right here, the only thing we get from this equation is the y-intercept, which is 72, and that would be here, 72. And again, when the ball releases your hit, when you throw a ball, when the ball, just before the ball leaves your hand, that's when you start your timer, if you're timing something. So that would be time 0. As soon as the ball, like the split second it leaves your hand. Okay. So therefore, the height of the cliff in this case is 72 meters. Now, once you get used to doing this, then we won't need to do this step anymore. Now, the next part is, what was the height of the ball after 4 seconds? So now it's the exact same problem as we did here. And I'm just going to show you how it's almost exactly the same. So now we start by writing out the equation. It's always the first step, the equation, or if we're dealing with the formula, then we do that part first. The second step is to do the substitution. Height of the ball after 4 seconds. 4 seconds is time, so we replace the t with 4 in each of the places where you can see there's a t. And now we are going to do, so this is going to be, I'll do an extra step here, negative 3 times 4 squared is 16, close the bracket, plus 4 times 6 is 24, plus 72. So now we're going to do one more step. And let's simplify that. So a negative 3 times 16 is 16 and 16 is 32, and 32 and 16 is 48. So it's a negative 48 plus, oops, negative 48. 8 plus 24 plus 72. So now you might need a calculator for this. So a negative 48 plus 24 plus 72 works out to be, I did something wrong here. Okay, so let's do that again. So 24, sorry, negative 48 plus 24 plus 72 works out to be 48. Oops. Negative 40 plus, okay, so that works out to be 48. And again, the units would be 70 or meters. So therefore, height of the ball after 4 seconds is 48 meters. And what we're going to do in a moment is we're going to graph this, and we're going to show that these can be verified using the graph. So I wouldn't say prove, but we're going to show that the answers we receive actually make sense. How long did it take the ball to reach the ground? So when does the ball, so let's start here. So this one is, we've got to do a little bit of thinking here. How long did it take the ball to reach the ground? So when the ball reaches the ground, the height of the ball above the ground is 0. Okay. So when, oops, the ball reaches the ground, H will equal 0. So height of the ball is going to be 0. So again, let's make this red. So now again, what we need to do is start off with the original equation and put it in here. So there we go. So now we have to do the substitution. So the ball reaches the ground at H equals 0. So in that case here, H is 0. Actually, let's do it this way here. So my H value is 0, and in that case, we're going to solve for T. So the only way we can solve for T, because it's a quadratic, it's a quadratic equation, because we have a T squared term and a T term, and so there's going to be, usually with all of these, just going to be two possible answers, just like the ones we worked on a couple days ago. We have to solve this by factoring. So now we have to, we're not going to common factor, we're going to factor the trinomial. But before we can factor the trinomial, we have to factor out a negative 3 because the t squared term has to be by itself. So I need to factor out the negative 3. So negative 3t squared divided by negative 3 is t squared. 6t divided by negative 3 is going to be a negative 2t. And plus 72 divided by a negative 3 is going to be a negative, so minus, and 72 divided by 3. And again, if you need to use a calculator, that's fine. It's going to be 24. We'll close the bracket. So what we've done now is we've common factored. So I'll just put that over here for you. Oops. I'm going to come outside of here if I can. So common factor. So we've done that. Now we're going to factor the trinomial. Factor the trinomial. You don't need to, but I'm just doing this so that you understand what we're doing. You don't have to write this down when you're doing a solution, but you should write this down when the ball reaches the ground, h equals 0, and so on. So now, oops, we have to factor this particular trinomial. The minus 3 stays the same, so now t squared is going to become t. Oops. So -3 bracket. Let's get rid of all of this here now. So we have t squared minus 2t minus 24. So we know that the first term inside of each binomial will be t. And the last term we get by multiplying, and the only way to get a negative answer when we multiply is we have to multiply a positive number. So it's going to be t plus something, and then it's got to be t minus an integer. Okay, so so now we have to figure out which two numbers will multiply to give us a -24 and add together to give us a -2. So negative number, when we multiply, one positive, one negative. If the number in the middle is negative, the bigger of the two numbers has to be negative. So in this case here, 6 times 4 is 24, and 4 minus 6 is -2. So there we have the trinomial factor. So now we can determine, now don't forget that the zeros or the roots are the x-intercepts. And the x-axis in this particular problem represents the ground. And the y-axis represents the cliff. So we've used the y-intercept form to find the height of the cliff. So now this is going to tell us how long it takes the ball to reach the ground. Okay, so that means, and if we multiply a -3 times t plus 4 times t minus 6, and the answer is 0, then don't forget from problems we worked on last week, that means that either one or the other has to be 0. Because the only way to get a 0 answer when we multiply is if one of the two numbers is actually 0. So I'm just going to copy that. So now in this case, we're not dealing with x's, we're dealing with h. So it means that h plus 4, sorry, t plus 4, t plus 4 is equal to 0, or t minus 6 is equal to 0. If t plus 4 is equal to 0, then the t is going to be the opposite of 4 with the opposite sign. So t, in this case, would be -4. And in this one over here, t is going to be +6. Now, in some situations, and this is one of them, so the roots are, oops, t equals -4. I'm just going to this a copy, and t equals -4. and t equals +6. So we can't have negative time. We can't have negative time, therefore t equals 6. Okay, so therefore t is equal to 6. So now we can say that the ball, how long, the question says, how long did it take the ball to reach the ground? We can say it takes the ball, or it took the ball 6 seconds to reach the ground. And again, we're going to show all this in a few minutes now when we go to look at this using decimals. What was the maximum height that the ball reached above the ground? This one we're going to have, because we don't have any other way of doing this right now, we're going to get this information when did this occur. So we're going to get this information. The solution in this case is going to come from the graph. Okay, so let's do this. And we'll just state that down here as well. So we're, oops, I'm going to make that a little bit narrower so we can see it all on the screen. So solution. Okay. We will get this information from the graph. Okay, so now let's get into here and get into decimals. And what we want to do is, I want to scroll back up here so I can see the equation. Now, here, when we're going to graph this, we could probably use H's and T's. Well, let's try that. I've never tried that. So H equals a -3t. Yeah, so we can even use, and we're going to square that. Okay, I'm going to maximize this for now. Get over there. Okay. Oops. -3t, shift number 6 to get the square, -3t squared. So again, what I like about this particular program is it shows you the parabola as we enter the data. Plus 6t plus 72. So there is the graph, and -4, +6. The -4 we're not interested in because it came before the graph, before the cliff. Not interested in that, we're only interested in this part. So the only part of the graph that we are actually interested in is the part from here, from the y-axis, up and down to the x-axis. And that is exactly what the parabola would look like if you were to take photographs and just plot the path the ball takes. So there we go. We can verify that, yes, that is indeed 6, 0. That is where how long it takes to hit the ground. And it crosses the y-axis at 0.72, and that's what we found in part A. And after 4 seconds, so 4 seconds would be 2, 4. After 4 seconds, the ball is right no, after 48 meters. First 0, 2, 4. So it's hard to tell here, but if we zoom in, 4 and 40. So after 4 seconds, the ball is at 48 meters above the ground. So that's verified. How long did it take it to reach the ground? We said reach the ground. And again, we can come down here after 6 seconds. And the next part is we're going to, what was the maximum height the ball reached above the ground, and when did this occur? Okay, so let's take a look at that. Let me just get out of here again now and come back into, okay, so if I move this over. So the maximum height the ball reached, we got to go to the very top up here. So the very top, right there, is 1 comma 75. 1 comma 75. So after 1 second, the ball is at 75 meters above the ground, and then it starts to fall towards the ground. Okay, so 1 and 75. So let's get rid of that for now. Oops, and get my graph. Come on. Okay. So let's answer the question. So it says, what was the maximum height the ball reaches above the ground? The ball reached at a maximum height of 75 meters, and this occurred after 1 second. Okay. So there we go. So we can determine a lot of information based on the information or the equation that we're given. So if you, like I said, if you were to take a ball and throw it in the air and do this, and you were to take a photograph, and then you were to take that and put it on top of a piece of graph paper and plot the grid, you could actually come up with the equation. And that's what they actually do to find the equation. Okay? So that's about it for quadratic equations. And that's going to be it for this particular, actually, not quite yet. We're almost finished the lesson. So I'm going to just do a couple of more examples of factoring. So the one that's on the screen, x squared plus 7x minus 30 equals 0. And this is right from the support questions in your module. So I'm just doing this one to show you how I want you to do them. And this would be the solution. So I want you to do it just like this. You don't need to write out all of the factors. Just do it like so. So x plus 7x, x squared plus 7x minus 30 equals 0 is x plus 10 times x minus 3. So therefore, x equals negative 10 or x equals 3. And the roots are x equals negative 10 and x equals 3. So again, fairly not a difficult thing to do, and the solution is not long, but do it in steps like I've done, and try to do it in using the spacing that I've done as well. So everything's not jumbled together and one big clump type thing. Spread it out, make it look neat and tidy. So the rest of this particular one and number 2 are done the same way. Then we're going to scroll down and they talk about what the x-intercepts are. Shows you right there what they are. And so this particular support question number 5, it lists 1, 2, 3, 4, 5, 6 different quadratic equations. and they're all in what we call the y-intercept format. So they're all trinomials. And what you have to do, you have to factor each of the trinomials to find the zeros, or another word for zeros are x-intercepts. So find the x-intercepts. And once you find the x-intercept, you have to decide which one of these six graphs represents that equation. So I've done the first one for you to get you started. So x squared minus 6x plus 8, multiply to give you positive 8, add together to give you negative 6. So when you multiply, the answer is positive, so that means you have to multiply two positive answers or two negative answers. If you add two positive If you multiply two positive numbers and you add two positive numbers together, you're going to get a positive answer. But here the middle term is negative. So the only way to get a negative middle term is we have to multiply two negative numbers. So negative 2 times a negative 4 is a positive 8. And negative 2 plus a negative 4 is negative 6. So x squared minus 6x plus 8, when that's factored, is x minus 2 times x minus 4. So when we multiply again, if the answer is 0, then one of the two numbers must be 0. So that means that x minus 2 must be 0 or x minus 4 must be 0. If x minus 2 is 0, then x must be 2. If x minus 4 is 0, then x must be 4. So that means that the roots are x equals 2, x equals 4. So when I look at this one here, the vertex is right at negative 3. Nope, not 2 and 4. This one, the x-intercepts are 1 and 1, 2, 3, 4. That's not it. This one, the intercepts are 1, 2, 2, and 4. And that is indeed what we're looking for. X-intercepts of 2 and 4, which would be this particular one here. So the answer would be this equation represents graph number 3. Again, you can always check these by going to Desmos and then graphing it and verify your answer. But do the math first, factor, determine the zeros or the roots, pick the equation that you think is the correct answer, then check it on Desmos. Okay, don't do Desmos first. When you send out your work to be graded, if this were a key question, then most of the marks are going to be based on your solution here, and only a small percentage of the marks were based on did you get the right graph. If you only chose graph number 3 and you didn't show any of this work, so 1, 2, 3, 4, let's say there's 5 steps in total, I would probably give you 5 marks, and the graph would only be 1 of the 5 marks, or 20% of your mark. So you're not going to pass. So show all of your work. So there is a solution. One of these is done for you. So once you've picked a grid, then that doesn't can't be there twice. So there are 6 equations and 1, 2, 3, 4, 5, 6 graphs. Okay, so one for each. So keep that in mind. Again, this is a support question, and I can help you with these if you want. There's a similar problem in the key questions as well. Not as many graphs, though, just 3. So do the practice ones first, and then you're ready to do this one after you're done there. So that is it for lesson number 3. So now that finishes the 3 lessons on quadratics. We've looked at 3 forms of the equation. Each form of the equation gives us different informations. You're now familiar with Desmos and how to use it to help you graph, or actually does the graph for you, and then we can get information from there. And again, you can use a graph to verify your solution to word problems, for example, like the one we did today. So do the graph, do the equation, and then plot it on the grid. So let's move on to lesson number 4, which is going to be exponent laws. And you've probably seen most of these, if not all of these, in grade 10. So what I'd like to point out before we get started is there is a website, and the link is listed here. So I'm just going to click on it to show you what it's like. So here we go. law of exponents. And the neat thing about this is it explains all of the rules. And I'm going to go through this with you in a moment, but it allows you to change this number right here at the bottom is called the base, and the part that's raised to the power is called the exponent. So I can change the exponent to see what happens, and I can even go into the negatives. Okay, so it allows you, just like when you're using Desmos, when you change information in the equation, the changes are made on the graph instantly, so you can compare or you can see what's going on as you're doing it. So this is a fairly neat uh, website. The one thing I want to point out is what does it mean when we have a power? So the example they use here is 8 to the power of 2. And 8 to the power of 2, we usually say 8 squared. If it were 8 to the power of 3, we'd say 8 cubed. But if it was 8 to the power of 4, we'd say 8 to the power of 4. 8 to the power of 5, 8 to the power of 6, 8 to the power of 7, and so on. It's only the square, 8 squared, or the cubed, the exponent 3, that have special names, squares and cubes. The rest are just to the exponent or to the power of. The number at the bottom is called the base. And then the number that's in the upper right corner of that base would be the exponent or the power. Sometimes called an index, but we don't see that very often. It's either 8 to the power of 2 or 8 exponent 2, but most people say 8 to the power of 2. So if you want to play around in this website, it does go into all of the exponent laws, and it does a good job of explaining what negative exponents mean, what a zeroed exponent means, and so on. Okay, so I'll let you, if you want, go in here and play around, and it can provide a lot of assistance. Not all of what's on the website are we going to cover in this particular course. So what's on the top for sure. So we'll leave that for now, but you're more than welcome to go in and check that out. So let's go back to here. The There are a series of laws, and or we usually call them exponent laws or laws of exponents, or it doesn't really matter what you call them, but they're exponent laws. Typically is what you hear refer to them as. So they're explained in detail in the lesson material that you receive, but I'm going to just skip down over that because that's there. You can read that on your own. And if you need some help understanding what's there, please feel free to give me a call. What I would like to do is go down below here and talk about the exponent laws the way that most textbooks refer to them. And we're using variables and exponents that are letters. So the first exponent law is when we have the product of two powers, and when we're multiplying two powers. Now, when we're multiplying powers, we have to make sure that they have the same base. And when we multiply two powers with the same base, so a power would be a base with an exponent. So here, a to the power m times a to the power n. A is the base in each one of these, so the bases are the same. So now we can use the exponent law. So a to the power m times a to the power n is equal to a to the power m plus n. And we'll look at some examples a little bit later to illustrate these laws. The next one is the division law. So when we divide two powers with the same base, we subtract the exponent. So a to the power m divided by a to the power n is equal to a to the power m minus n. Now that can be written like this, but typically in high level mathematics, so grade 11, grade 12, and university, we write division this way over here. So we're going to say a to the power m over a to the power n, so like a fraction. This means we are dividing a to the power m divided by a to the power n equals a to the power m minus n. And m and n can be any integer, and a can be any integer as well. The third law says when we have a power to a power, so when we have a power to a power, we multiply the exponent. So a to the power m to the power of n is equal to a to the power m minus n, sorry, m times n. And what I'm going to do in a little while, once we went through all of the laws, I'm going to do some examples to show why this is true. You'll see very clearly that this makes sense. A to the power 0, this is the zero exponent law. So anything to the power 0, it doesn't matter what it is. It can be a number to the power 0, it can be any number, and it can be a variable to the power 0. It can be any variable. It doesn't matter. The answer will always, always, always be 1. Okay, so if you see an exponent 0, automatic answer's got to be 1. And I'll show that. I'll show an example a little while again to show why that is indeed the case. And the last rule we're going to take a look at, or the last exponent law, is when we have a negative exponent. So a to the power negative m is equal to 1 over a to the power of positive m. Okay? So negative exponent means it's simply going to be a fraction, 1 over the same base, the same exponent. Only difference is now the exponent turns to a positive. So the negative m becomes a positive m. So a to the power negative m is 1 over a to the power of positive m. So those are the exponent laws that we are concerned about in this course. There are one or two others that we're not going to get into, but if you go back to that website that I showed you at the top, it will go into the other ones as well that we are not going to deal with in this particular course. I'm just going to point out one thing before we end for today. So simplify in the material that you received. It said that we simplify uh, when we have a positive exponent, so no negative exponents. But really simplify means we want to work it down and get a numerical answer like we did up here. So anything to the power of 0, again, always 1. And we didn't work these out here because 6 to the power of 28 would be a really, really, really big number. Like, and so we left them as a positive or just a positive exponent. So in some cases, it might say simplify and then leave as a positive exponent, or sometimes if it just says simplify, it means we want a answer. So I'm just going to see if I can get 6 to the power of 28 would be 6.1409. So it will be 6 and 21 digits. So what would that be? You'd be well up past the trillions. I know what comes out because a trillion would be 9 would be a million, a billion would be 12, 15 digits would be a trillion, and this number would have 21 digits, 22 digits. So I don't even know what that would be. It's a really big number. So that's why we have exponent laws so that we can write really, really big numbers by using a few digits. So 6 to the power 28. Okay, so that's why we use them. So if you look here, I've actually worked out what 1 over 2 to the power 1 would be as a fraction. It would be 1/2. 1 over 4 cubed is 1 over 4 times 4 times 4, which is 1 over 64. 3 to the power of 6 is 3 times 3 times 3 times 3 times 3 times 3 is 6 of them. That's what the power means. The power means how many bases there would be when we multiply. So we're going to have 6 threes, 1, 2, 3, 4, 5, 6. If you do that in your calculator, you'll get 729. 4 over 3 squared means 4 over 3 times 4 over 3. When we multiply two fractions, we multiply the two denominators, or sorry, numerators. 4 times 4 is 16, and then 3 times 3 is 9. So this would be simplified as far as we could go. Okay, so that's as far as we're going to get today. We're going to pick up from here tomorrow, and we'll continue working with exponent laws. Thank you for participating, and I look forward to talking to you again tomorrow. Bye for now.